Hi, everyone. Welcome to Powering Autonomous Delivery Logistics at Matternet. Really glad to be a part of this first ever HasuraCon. And yeah, let's get right into it. So first things first, my name is David Tsai. I am a software engineer at Matternet, and I help lead the client software team. And you can find me online at GitHub under Tsai David. Or Twitter under Tsai_Borg, though I can't guarantee the quality of the content that you might find there. So moving on, sort of first things first, I'd love to really chat about our agenda for this talk. We should first go over what is Matternet and talk about a primer on some of the technologies that we will cover today. And then finally, discuss the architecture, which is we'd like to think of it as before Hasura and then after the introduction of Hasura. And finally, we'll wrap it up with a really short recap. And before we do that, I'd like to show you a video which kind of demonstrates what our company does, which is a autonomous end-to-end delivery logistics platform. So I'm going to go ahead and play. Cool, awesome. So hope you guys enjoyed that video, and it really serves to highlight the mission that we're trying to accomplish here at Matternet, which is to make deliveries, especially in the healthcare sector, more easy than ever. And what's really interesting is that the fact that COVID-19 has happened in the pandemic only accelerated the sort of need and reception towards contactless delivery. So we always knew this was going to be a part of the future, but kind of the current state of the world has, again, just really pushed us forward there. So to begin, let's cover a couple of technologies that we're going to see shortly. The first is telemetry, which is, for those of you that don't know, remote data collection and measurement. So that's going to look like, altitude, temperature, various sensors that we might have, whether on a ground station or the aircraft itself. And MQTT is really popular in the IoT world. It's a pub/sub protocol. And, with pub/sub, you'd have a broker. So in our case, we use HiveMQ, but again, there could be different brokers for that. Protobuf is it's for data serialization, and the important thing about that is that the data is structured. So that came out of Google, and they were trying to think kind of somewhere along the lines of XML, but they really wanted it to be smaller and faster. And then with Kafka, that's a tool that came out of LinkedIn, and It does distributed stream processing, log aggregation, all sorts of cool stuff. And so we take really good advantage of that, and we'll explain in what manner shortly. And finally, a word that you might hear is mission control. So this is actually our product that we've developed to help command and control aircraft, especially as it relates to critical flight operations. And just as a reminder, Matternet as a company, these products that we're working on, this is happening in an environment that has been vetted by Swiss FOCA and FAA, United States FAA. So we've been approved to fly beyond visual line of sight and regularly perform deliveries in the healthcare sector, transferring blood samples and whatnot. Cool. So let's jump into the architecture. So in order to really best understand how GraphQL, and in particular how Hasura has actually benefited us, we have to really quickly look at a previous iteration of the architecture. Please keep in mind that this diagram that I'm showing here is definitely a simplification of the full system. And it represents just the most common system level interactions between the various building blocks. In particular, it's just going to be the aircraft and some of the client software, because that's the focus of today's talk. Right, so with that being said, the first things first is to actually take a look at the aircraft and the other various assets that we have here. The MQTT is the actual protocol, the IoT pub sub, but the messages are being encoded using protobuf. We have a broker involved, and that kind of passes that along the various topics to our clients. So one of the first problems that we started seeing was it made it really difficult to add additional clients or other applications because there was quite a bit of a tight coupling, since the clients themselves needed to have the generated protobuf code in order to deserialize the message and kind of interpret that. So that's going to be one of the first points, right? Is cumbersome and inconsistent APIs. We have clients dealing with a GraphQL API that we started to implement. Keep in mind, this initial implementation was done using Apollo Server. And so we started to see sort of the impact of that play out, the benefits of GraphQL really in our mission control. But we still had to juggle the fact that mission control was also getting a real-time telemetry over this direct connection to MQTT. And finally, we also have other REST APIs that one of our native apps would take advantage of. So again, inconsistent APIs. So a lot of business logic and data processing for our clients. And you see that play out with, again, we mentioned the protobuf messages coming through, and then we saw the tight coupling. And finally, because there's a lot of this ephemeral data, stateless data, passing through over telemetry, what was happening is we actually didn't get really good visibility into a lot of these transactions. And so that made it really hard to debug at times. So what do we need then, right? So first off, we wanted to kind of consolidate and create a GraphQL gateway of sorts for these APIs. Our developers really fell in love with GraphQL, and when combined with TypeScript and Apollo React, it was really easy to build out these applications in such a way, and we wanted to continue to maintain that and streamline that. Secondly, we wanted to start to decouple these clients from the protobuf messages. The protobuf was used to, it's a data format, but it doesn't help manage how the data is being used. And we didn't find that it was appropriate to actually do that on the clients. And in fact, it slowed us down when we did need to make breaking changes to this rapidly evolving R&D that we were doing. And then finally, we wanted to be able to leverage things outside of just the traditional CRUD model, right? So with Apollo, what we realized is although we wanted to be centered around sort of the schema first development, what we quickly discovered is it very much reflected not only standard CRUD that we were implementing from scratch all over again, but we wanted to be able to take advantage of this command and query model that we really think in the later slides you'll see how Hasura's actions helps take care of. Cool. So let's look at our new architecture. So first of all, you'll notice there are quite a few number of changes. The first being that we were able to consolidate and simplify significantly the APIs for a growing suite of applications, right? So as time went on and customer requirements change, we wanted to be able to stay light on our feet and be able to build things out appropriately. So having this consistent GraphQL interface for all the various applications, whether it be a native application, other web apps, or even Electron apps, we're able to take care of that with ease. Secondly, one of the points that we struggled with again was decoupling, that the fact that the clients were really tightly coupled to the protobuf messages. So we were able to solve this by the introduction of a Kafka cluster, which you'll see here. So the Kafka cluster has a bunch of stream apps in it, and it's managing the streaming data. And what that enabled us is to really normalize the data and prepare it in such a way that would make it most appropriate for these clients to actually consume. Okay, so I think at this point, the best way to understand how kind of this new system really works is to walk through an example of it. So let's look at our aircraft and how Hasura Actions kind of steps in to save the day. Awesome. So at this point, we're going to talk about mission control, right? So just as a reminder, mission control is this mission critical system, right? That has to be not only certified, but has to have specialized users, flight directors, we call them, operating, because they're going to keep an eye on the various flights. And although the actual aircraft and the platform is designed to be autonomous due to regulatory needs and whatnot, we still need to have human operators at least monitoring various aircraft as they are sort of performing their duties. So mission control is written in TypeScript. It's a Next.js React web app. I know a lot of buzzwords. And then it's deployed on Vercel, artist formerly known as Zeit, in a serverless fashion. And we really, really love being able to take advantage of Apollo Client's hook-based architecture. So anyway, let's jump right into the actual use case. So, if I'm going to play the role of a flight director, I want to actually start a flight, right? I want to perform a delivery. So first off, mission control, I log on to mission control, I'm signed in, I have my workstation all prepped. And what actually happens in the background is mission control is establishing a WebSocket connection to the GraphQL engine. So this is Hasura. And in this example, I want to be able to take off, right? I want to start my day, I want to start one of the deliveries that we've promised. And so what I'm going to do is in the UI, I can actually issue a takeoff command. So I'm going to click a button and do that. At this point, the command makes its way over to Hasura GraphQL engine. So remember, all the GraphQL operations are happening over this WebSocket connection. So we have a mutation being sent over to actually tell the vehicle or aircraft at some point to actually take off. So at this stage, we have an action handler rigged up. So that's what we see here. And so what happens is Hasura validates that mutation and then it delegates it to the action handler. So this is really good for us because as we continue to scale, um, we benefit from horizontal scalability because we can just simply add in more handlers to take care of some of the stateless processing and really be driven or inspired by some of these event-driven systems we see out there. Okay, so the third step is to actually construct the message, right? So again, earlier we talked about how we wanted to be able to tap into this command and query mental model, right? So things outside of the traditional create, read, update, delete, CRUD. So at this point, we have the action handler, which just so happens to be a node service, and it's going to construct a message, meaning it has the necessary tools to build the protobuf message, and then it's going to encode it and then throw it onto the correct topic. And at that point, it makes its way to our broker. So because our aircraft was, subscribed to the correct topic, it now receives the message, right? So what it does is it deserializes the data, and then it, step 5, responds. So because it received a message to actually take off, at this point, our aircraft is responding because it's constantly publishing its telemetry. So its flight status actually changes, right? So its flight status goes from, armed to taking off. Cool. So at this point, this is where stream processing comes into play, and it really helps us to consolidate our systems. So the first thing that happens is within this Kafka Stream app, we're doing all sorts of different things, and it's very much event sort of, or I guess I would say it's very much inspired by event-driven systems. So we deserialize the data, right? So we decode the protobuf, and then we want to normalize it too, right? Because we want to transform the data in such a way that it makes the most sense for the end users, the clients, these front-end apps that we're talking about. And previously, as a reminder, the clients were responsible for deserializing that. So we've actually unburdened the client and moved that to this Kafka stream. And because we live in a world where there are tight regulations, especially with FAA oversight, et cetera, it's not always possible to just change all these various products and then keep them in sync. So by bringing them into the Stream application, we're able to more easily manage some of those things. So the next thing that happens now that the data is kind of normalized and deserialized, we can actually write to the appropriate tables. So we're going to update the database, and it is now ready for any future analysis that we might have, but also direct client consumption, right? So because Hasura is sort of attached to the hip to our Postgres instance, we can now reflect that over the real-time architecture that Hasura provides. So now you see how this thing comes full circle, right? The client issue, the user, me as a flight director, I might issue a command to take off, makes its way to the handler, to the aircraft, all the way back down, and kind of ends up as a real-time update to my interface, right? So now I see that the aircraft status has changed from armed to taking off, and I see all sorts of other telemetry, the altitudes being changed, etc. Awesome. So that wraps up, one of the really crucial aspects that we love about Hasura, which is getting to leverage actions and how we can issue real life commands to aircraft that's actually operating out in the field. So one of the other things that we wanted to really add in here is the fact that we were really able to easily tap into Hasura to create a partner API. So because we've been benefiting so much from using GraphQL ourselves, and it kind of fit into this trend of increasingly using type safe systems or more type safety or strongly typed languages, etc. We kind of felt like GraphQL is a perfect investment, and that could give our partners something really useful and easy to work with. So we were able to accomplish this with Hasura because with Hasura Pro, we were able to introduce not only rate, but query depth limits. And that's really important for anyone who's ever worked with GraphQL because you don't want to allow sort of recursive queries by accident. Additionally, there are all sorts of role and permissions things that you can set up on Hasura. So that makes it extremely easy to configure a separate API, but all on the same GraphQL engine. And then finally, earlier we mentioned the inability to have analytics. Well, with this, because of the visibility that we get using Hasura Pro, we're able to identify slow queries that our partners over at UPS were dealing with, and we're able to kind of simplify that and optimize that for their use cases. And finally, just as a recap, this has been a very simplified explanation of our otherwise quite complex architecture, but we hope you've learned a couple of things. I wanted to recap by saying that Hasura has helped us to get consistent APIs, right? We were able to build a consistent API for the various growing number of client applications. And we're able to keep that sort of type safety end to end. We were able to streamline the clients because we also removed the need for them to have so much business logic and really focus on them as a presentation layer only. We were able to leverage this command and query mental model through the use of Hasura actions. So that has been really awesome. And we also love the fact that they've recently added the ability to not only do mutations, but queries as well through this, their Hasura actions. And finally, we're able to really quite easily bootstrap together a solid partner API that could be tailored for their needs without too much overhead on our part. So once again, thanks for listening. You can find out more about our company at www.matter.net, mttr.net. And we're always looking for awesome engineering talent. So if you are interested in autonomous drone deliveries and want to get involved with a company like us, whether you're DevOps or you are a full stack software engineer, please feel free to connect with me or reach out to one of us at the company. Thanks.